At the job site, the backfill was transferred to loading hoppers and hauled by truck to the embankment area. It was a very coarse aggregate, and although it did not require compaction, it was sluiced into the fill. This is a portion of the completed wall. The seepage is from the water used to sluice the embankment down behind. This is a portion of the underside of the cantilever sidewalk. And a portion of the sidewalk being constructed. The hand railing for the sidewalk was precast in the framing yard on the job site and constructed in place.
In many homes, it is one of our most useful handymen. It cooks our food, heats our water and our home. For the farmer, it can generate his power, warm his chicks, fuel his tractor, and control weeds through flame cultivation. And what of industrial uses? Well, LP gas serves, among other things, textile industries through drying processes. It can operate that workhorse of the factory, the forklift truck. And heat treat metals for 1,000 industrial uses. LP gas prevents railroad switches from freezing and thus keeps the trains running. One important use is providing the cooking fuel for restaurants throughout the nation. Last year, 6 billion gallons of LP gas were transported and sold in the United States. Now, how would you transport this liquid fuel that boils well below the freezing point of water? The oil companies solved the problem by developing specially built tank cars and tank trucks, permitting LP gas to be handled and stored in liquid form. 1 cubic foot of this amazing liquid becomes 300 cubic feet of vapor, which will do the work of 750 cubic feet of natural gas. A major achievement of the competing oil companies has been the development of techniques for successfully transporting and handling liquid fuel in great volume and at low cost. Here's a man who wears 2 hats. Of course, he's only wearing 1 hat now. That familiar one you see every time you drive into your neighborhood service station. Perhaps you've already found out he's one of the most conscientious citizens of your town. In addition to his regular occupation, he may be also a member of one
Yep. Just come in tight on that base. Yeah. You want the next one? Where is it? There it is. Good.
Water in the Pacific Northwest. It's a resource that is relatively abundant, readily accessible, and closely associated with the identity of the region. Clean, fresh water is a basic necessity of life, and the Puget Sound
Your construction jobs, National Engineering Department, during 1934-35 was the project known as Railroad Avenue Seawall Improvement. The scope of work consisted of approximately 6,800 feet of seawall, an embankment fill of over 300,000 cubic yards, water mains, sewers, paving, and so forth. The limits of the project extended from Bay Street on the north to Madison Street on the south along the Seattle waterfront. The scenes you are viewing are in the vicinity of what is now Pier 55 and Pier 56 between Seneca and University Streets. According to the engineer's report, many studies had been made of both temporary and permanent developments. Both types were considered, but since preliminary cost estimates on a permanent plan ran into enormous amounts of money, the work was postponed time and again. A design was finally worked out that combined the permanent features with the use of timber and wood of the more temporary types. Since the cost of this plan was far below the lowest possible of the more standard types of seawall, and adjudged to be permanent, it was adopted and used for the project. Railroad Avenue was a street which varied in width from 140 to 180 feet. It was carried largely on timber trestles. It had become more and more inadequate. Large sections of the street had been blocked off and closed or limited to light loads. Both vehicular roadways and steam railway trackage along the waterfront occupied the street, and considerable confusion was the result. In January 1934, the city of Seattle undertook this improvement by the use of day labor, following the failure on 6 different occasions to receive acceptable general contract bids. From time to time during the course of work, various individual contracts were awarded for such work as pile driving, manufacture of wall slabs, premixed concrete, and backfill material. All of the work was by city employees. It was said in 1934 that if the Board of Public Works had not ordered the start of work by Monday, January 15th, the city would have. From the beginning, Seattle's progress has been linked with its waterfront. The waterfront has been Seattle's economic heartbeat since 1878. The central waterfront thoroughfare was called Railroad Avenue. Built from 1885 onward and patched and pieced together over the years, Railroad Avenue became a confusion of railroad tracks and trestles. Railroad Avenue was a street that varied in width from 140 to 180 feet. Since it was supported largely by timber trestles, it had become more and more inadequate. By 1930, large sections of the street had been blocked off or limited to light loads. Both vehicular and steam railway trackage along the waterfront occupied the street, and considerable confusion existed. A major construction program on this waterfront, with its soft foundation and 16-foot tide range, was essential to modernize the harbor line. The city engineering department made many studies of both temporary and permanent developments. But since cost estimates ran into enormous amounts of money, the program was postponed time and again. A design was finally worked out which combined the permanent features with the use of timber and wood. Since the cost of this plan was far below the lowest possible costs for a more standard type seawall and adjudged to be permanent, it was adopted and used for the project. It must be remembered that the seawall design was a compromise plan, combining concrete, steel, wood, and aggregate backfill. The main features of this design were the use of precast concrete wall slabs, which removed the necessity of expensive cofferdams, sheet piling to protect the fill, timber piling foundations, and relieving platforms to carry the weight of the fill and prevent settlement into the soft bottom of the shoreline. Aggregate backfill, which will be hauled in later by barges. The design included moving the railroad tracks to the east side and paving the street to carry traffic on top of the filled area. The limits of the project extended from Bay Street on the north to Madison Street on the south.
The Street Lighting Division has put together a tape depicting the replacement of certain poles in the Central Business District of Seattle. These are poles that have been removed and replaced, and we're showing the removing of the copper skin from the steel shaft. When the skin is removed, the outer skin is removed, it will be noted that there's a large amount of rust and shale on the steel shaft inside, particularly around any holes that have been bored in this pole in the past. Here we're chipping away some of the rust and shale. We're not actually cutting this, just chipping it loose.
Schools and government institutions, while the remaining 10% is used by commercial businesses and industry. In addition to supplying residential and industrial needs, water from the Cedar River makes up the bulk of fresh water flowing into Lake Washington. This helps to flush the lake, maintaining water quality, and support sufficient lake levels for navigation and recreation. In the process, saltwater intrusion is prevented, where Puget Sound meets the Ship Canal at the Ballard Locks. Aside from their featured roles in our water supply, the Tolt and Cedar Rivers are also habitats for sport and commercial fisheries. In fact, the Cedar hosts the largest sockeye salmon run in the continental United States. Water from the Tolt and Cedar Rivers are part of a closed-loop system, and to some extent, supplies can be interchanged. Demands on the water system vary with weather conditions. Hot summer days in the midst of extended dry periods can present difficult supply challenges. The capacity of our mountain reservoirs is limited, and therefore, any prolonged interruption in their resupply can have an impact for months to come. For example, an early snowmelt or lack of rainfall can cause water reserves to seriously dwindle as warm weather demand picks up. For such unplanned events, the Seattle Water Department follows a water shortage response plan. Current studies indicate that this area could outgrow its existing water system in the not-too-distant future. Before this occurs, however, either new supply sources will be needed or the growth in demand must be curbed through successful conservation efforts. In recent years, a combination of both these alternatives has proven effective. In addition to adding new, limited water sources, such as the Highline well fields, residential, commercial, and industrial conservation is playing a major role in the current supply strategy. The Seattle Water Department's conservation program helps increase water use awareness and reduce waste. Since water can be stored within the system, every gallon saved in consumption is an additional gallon available for supply. The incentives for saving water do not end with simply stretching our supplies. Reduced usage forestalls the day when expensive new sources and delivery systems will be needed and lowers water, sewer, and electric bills. The water flowing from household faucets is only one small part of a complex, interrelated, and carefully managed water resource system. The Seattle water supply system has come a long way from the early days of the wooden flumes and pipelines. With the ability to deliver more than 350 million gallons a day, the system has kept pace with a continually changing environment. The Pacific Northwest has long been associated with its water resources. Through conservation and careful management, this association will continue to provide a regional trademark and a flow from the tap for years to come.
You know, we got pretty good water around here.
This is reinforcing steel protruding from the top of the wall slab, which will help form the cantilever sidewalk to be constructed later. Here we can see the wall slabs in place and the method by which the slabs were secured. You will note that the concrete shear beams are keyed. Concrete will be placed between them to form a solid slab. 1-inch steel rods were used as tiebacks to keep the wall in absolute vertical position. Concrete vibrators had not been in use many years, and an interesting sidelight here was that a reporter for one of the newspapers became so fascinated with this operation, he wrote a feature story on vibrating concrete at the seawall. The contract for furnishing ready-mix concrete was awarded to the Crosby Sand and Gravel Company. They were located on East Lake Avenue on the south side of Lake Union. They later became Pioneer Sand and Gravel. Their contract was for furnishing the concrete at the job site only. Placing it was by city day labor forces. The problem of keeping vehicular, rail, and pedestrian traffic operating at all times, both on the street and dock, cost many thousands of dollars to handle and added months of time to the date of completion. But the source of aggregate backfill for the project was the mouth of the Cedar River at the south end of Lake Washington near Renton. Barges were loaded by clam derricks and towed north through the ship canal and the government locks around to the job site. Seattle's waterfront is one of the most alluring of all visitor attractions in a city which has literally hundreds of colorful and unusual points of interest. The magic of the waterfront attracts visitors from virtually every state in the nation. It is an ever-changing spectacle of souvenir seekers and people who want to participate in the good things of life. But before 1935, it was not so convenient.
A blanket of crude oil is poured directly on the water. Water is jetted through oil for 6 months. Oil drilling mud was emptied into the water. Even dynamite charges were exploded near test oyster beds. Every possibility was explored. After years of study and progress, the results were in. The test oysters showed no ill effects from oil, even under conditions which far exceeded those ever present during oil production. As a matter of fact, the test oysters were so happy, they brought forth new generations to share their lot. They never had it so good. Well then, if this wasn't killing the oysters, what was? It took time and money to find out, and the scientists continued their progress. Oyster tissues were prepared for intensified examination and study. No possibility was overlooked. Finally, the real enemies are isolated. The most vicious villain of the lot is Dermocystidium marinum, a species of fungus that is bent on destroying the Louisiana oyster. It was further found that natural changes in the Gulf Coast and man-made improvements such as levees, together with climatic changes, were seriously affecting the proper mixture of fresh and salt water in the oyster bedding grounds. All of these factors were contributing to the reduction of oyster populations. Now that the true causes were known, action could be taken. These major conclusions of the Oyster Research Program are cheerfully turned over to the oyster industry. Why, you may ask? Why were the results of $2 million worth of research given to the oyster industry? It's because oil companies believe that maintaining good neighbors is just good business. As long as business and industry are free to lend a helping hand to each other, then everyone benefits.
Somebody else's. Right. Okay. Thank you.
Okay.
Thank you. Hi, baby.
Little boy is hogging the man.
Are you all done?
That's Pippi. That's good picture.
Want to get down?
Here's a picture.
Okay, let's go to the toy store.
That's cool. The thing from Rachel last time. You know what? Chloe Cures is really good because it looks like there's this little tiny Pippi and a big giant monster.
Postcard? Huh?
I gave him a postcard. I'm gonna get this. I gave him a postcard. I don't know what. Did I get this one?
The one to draw?
Between these and the raw material from which they come, there has to be a factory. The refinery is that factory. Just a few decades ago, a refinery was a primitive still, making only kerosene. Today, some of these great plants employ thousands of people. To many an American community, their establishment and growth has meant new economic life. Listen.
My job is painting, keeping the outside of all these pipes and columns in good shape. I used to live here before the refinery was built. Hunted rabbits in the brush where those alkylation units are now. There wasn't much doing over in town then. A lot of folks were even fixing to move out. But then the company moved in and set up this refinery. That gave new life to the town, new jobs. It meant a lot. Now almost every family has someone in the oil business. You know, every day a lot of oil products move out of here. All the time I'm at work, there's one jobber's truck after another coming in to get filled up.
One of the biggest carriers of both crude oil and refined products is the modern tanker, which with speed and economy
These are on a 19-foot aluminum pole. This is a 1,000-watt mercury vapor. These particular ones are on Aurora Avenue North. On a 28-foot steel transformer base pole. This is the flat lens McGraw Edison 250-watt high-pressure sodium on the concrete standards with a steel arm in Ballard. Need the post too?
Area's temperate marine climate and mountainous topography usually assure a steady supply.
We've got some important challenges coming up in the next few years on water supply. We have to keep a good water supply in our region. In the past, the combination of Seattle's larger system and many smaller systems in King County have met public needs really well. As we face continued growth, we'll have to work together to solve problems together to keep that water supply serving the public. We also have to consider the value of water as a natural resource. Obviously, there's a competition between our human needs for water and the needs of the environment, such as our important salmon runs in this region. In the future, I think we'll be seeing programs that use water more wisely and promote conservation as an important component of our water supply system.
In the early days, the native residents of this area, along with the first white settlers, relied on natural springs for their water supply. As the new town of Seattle took root, a crude network of wooden flumes was constructed to distribute this spring water more widely. Lumber mill operator Henry Yesler improved the system by using bored-out logs as pipes for water delivery to individual homes and businesses. The pioneer town soon boasted several private waterworks, which pumped their product from expansive Lake Washington to meet the increasing demand. The system proved useful for several years until the occurrence